Okay, 6.2, complex numbers. So we are about to embark on a journey of completely new set of numbers called imaginary numbers. So we now have eyes and things, and do not be scared by the eye. It just simply means that it is imaginary, and all that means on and we'll go into this later on when we start talking about what that means on a graph, but imaginary numbers just mean that they are not real. And if you had a quadratic function like this and it never touched the x-axis, then you would have imaginary roots. There would be two solutions that are imaginary, meaning they don't cross the x-axis. And so what that means when you're just looking at a number, anything that is the square root of a negative number is considered to be imaginary. Because you can't take the square root of a negative number, so the square root of -1 is considered I. So if you have a negative number under a square root, you would just call that I. So I to the first power is just the square root of -1. If I were to square that, so if I took the square root of -1 times the square root of -1, what would happen to that? What would happen to the square roots? They would cancel out, so I would just be left with -1. Because if you think about, like, okay, the square root of 2 times the square root of 2 just becomes 2. It's kind of the same concept. So when you have two square roots, or when you square a square root, so if I had the square root of -1 squared, all that happens is these two things cancel out and I'm left with -1. Okay, if I say that I squared is -1, I cubed is like saying -1 times I. Because I cubed is like saying I squared times I. And I squared, I know, is -1. So what's -1 times I? Just -I. And these right here, like I'm going to show, there are 4 of them that you just need to have memorized. So if this is not making sense to you, then I'm just going to say memorize these 4 properties of I. Like I to the first is the square root of -1. I squared is -1. I cubed is -I. And if I have I to the 4th, it's like saying I squared times I squared. So it would be like -1 times -1, which is a positive 1. Then, so every 4 exponents, it begins the pattern all over again. So I to the 5th power is going to match the same thing as I to the 1st. Exactly. So I to the 5th is the same thing as I to the 1st, so I can just say that that is I. I can say that I to the 6th is going to match whatever I squared is going to match. So I to the 6th and I squared will be the same, which is -1. So every 4th exponent, you repeat each other. So you only need to memorize I to the 1st, I squared, I cubed, and I to the 4th. And a way to figure out which one does it go with is by dividing whatever your exponent is by 4. And so if I take 5 divided by 4, it goes into 4, or 4 goes into 5 one time, and you're left with a remainder of 1. And so whatever my remainder is matches which 4 properties of I it goes with. So if my remainder is 1, then my answer is I. If my remainder is 2, then my answer is -1. My remainder is 3, my answer is -I. And we're going to do a few practice ones just to kind of solidify that. The next thing that I want to show you guys is simplifying radicals. So anytime you have the square root of a negative, automatically I'm going to put an I out here, and it's going to be the square root of 24. So I square root of 24. However, I don't want us to be done there because we can simplify this radical, meaning we can pull out the perfect squares. So what perfect squares are contained in 24? 6 and 4. 4 is a perfect square. So it's like saying I times 6, or I 6 times 4. 4 is a perfect square, so I pull it out and it becomes what? 2i square root of 6. So try 2, 3, and 4 on your own. Okay, is this what you guys got? Number 3, so with number 3, you pull out the I, and then 75 can be split to 25 and 3. And 25 is a perfect square. So when you take out 25 underneath the square root, it becomes 5 outside of the square root. So 5i root 10. Okay, let's look at the homework. Okay, we're just going to do, with these, examples are really just the best way. Okay, so working examples is really just the best way, and I'm going to show you like all of the different scenarios in which you would encounter one of these problems and then what to do with that. And also, the way that it will be phrased when you're doing a problem like this is that it's going to say simplify. So essentially what you're trying to do is simplify, like do whatever the operation says, whether that's multiply, add, subtract, divide. And then also you're looking for, are there any i's that have a greater power than 1? Like you can leave an I as an I, but if you have an I squared, you need to change that to negative 1. Or if you have an I cubed, you need to change that to negative I. So things like that. So if we look at number 5, if I want to simplify this, I would take this square root of negative 36, and what would that become? I square root 36, and the square root of 36 is 6. So I could write this as 6i. Then I could rewrite the square root of negative 16 as I square root 16, and the square root of 16 is 4. So 4i. When you're multiplying, you multiply the numbers together. So 6 and 4 becomes 24. And then you multiply the i's together. So I and I becomes I squared. Now, in order for it to be the simplest form that it can be, you do not want to leave I squared as I squared. I want to change this to be negative 1. So 24 times negative 1, which gives me negative 24. So my answer is negative 24. So never leave I squared. That's not the simplest it can be. You want to change that to be negative 1. Okay, the next example is kind of what I was talking about when you have multiples of 4. So anytime you have I to some really, really high power, what you will do is you will take that exponent and you will divide it by 4. So 82 divided by 4. So how many times does 4 go into 82? 20 times. When I take 20 times 4, I get 80. And I'm left with a remainder of 2. So 2 is my remainder. Since 2 is my remainder, it's going to match the same answer as I squared. And so my answer would be negative 1. Yes, Claire?
So how did you get 4? Like, why are you dividing by 4?
So you always divide by 4 because the pattern changes every 4 exponents. Yeah, so for every 4th power, it's going to repeat. It's like a pattern. So I to the 1st and I to the 5th are the same. Like every 4 exponents, the pattern repeats itself. So I always divide by 4 and then take whatever my remainder is. My remainder is either going to be 0, 1, 2, or 3, and whatever my remainder is matches with whatever power that is. So if my remainder is 0, it's going to match I to the 4th power. My remainder is 1, it's going to be I to the 1st. My remainder is 2, I squared, I cubed. And these are the 4 that you need to memorize. And so I to the 4th is 1, I cubed is negative I squared is negative 1, and I cubed, oh wait, I to the 1st is just I, and then I cubed is negative I. So these are the 4 that you need to memorize. Okay, number 7, I'm combining my like terms. So I'm going to combine 2 and then minus a negative 3. So 2 plus 3. And then I'm going to combine my i's. So negative 5i minus negative 8i. So negative 5i plus 8i. When you combine your like terms, you are left with 5 plus 3i. And since you only have I to the 1st power, you can just leave that be. You don't need to change it. No, these are easier. When you're just adding and subtracting, you don't need to multiply anything. So just leave it like that. So try number 8 on your own. Okay, number 9, I'm distributing the I. So I'm going to multiply 2i times negative 2, which gives me negative 4i. And then I'm going to multiply 2i times 3i. And that will become what? 6i squared, but I can't leave my I squared. I need to change that to be negative 1. So I'm going to rewrite this as negative 4i plus 6 times negative 1, which becomes negative 4i minus 6 as my final answer. Okay, number 10. Try number 10. You guys can do this one. We did one kind of like this. Okay, for number 10, you simplify square root of negative 81 to be 9i. You simplify the square root of negative 100 to be 10i. So 9i minus 10i just becomes negative I. For number 11, so this one is something that's a little different. This is like a special case. I think you might have learned in Algebra 1 that you can't have a square root on the denominator of a fraction. You didn't, then that is a true statement. Another thing that you cannot have on the denominator of a fraction is an I. So you can never have an I on the denominator. So no I's on the denominator. No I's on denominator. And so you must get rid of the I on the denominator. The only way to do that is to multiply by what, and so in order to get rid of the I on the denominator, I'm going to multiply by what we call the conjugate, or just the opposite. And so it's the same thing as the denominator, you just switch the sign in the middle. So if I have negative 2 minus 3i, the conjugate of that is negative 2 plus 3i. And if I'm going to multiply on the bottom, I also need to multiply that on the top. You can also call it creatively multiplying by 1, because essentially what I have written in orange is technically 1, because it would reduce. However, we have to multiply by this in order to get rid of the I on the denominator. And so I'm going to do that on the top, and we're just going to FOIL. So when I FOIL the top, I get 5 times negative 2, negative 10, 5 times 3i, so plus 15i, minus 8i, plus 12i squared. Then I'm going to do the same thing on the bottom. And what does this kind of remind you of when we were factoring? What kind of case is this?
Grouping.
Not a grouping. Like whenever I factor and I have like x plus 3, x minus 3, what is that called? A difference of squares, or you could do a difference of cubes, but this is a difference of squares. And so what happens is your middle term ends up canceling out. So whenever I FOIL this, I'm going to show you how the middle term ends up canceling out. And that's what it takes in order to get rid of the i's. So when I FOIL this, I get positive 4 minus 6i plus 6i minus 9i squared. And so the reason why I multiply by the conjugate or the opposite is because these middle two terms end up canceling out. And that's how I get rid of the i's on the bottom. So similar to when you have like x plus 3, x minus 3, if I FOIL that out, this is the exact same thing. I'm kind of like making this a difference of squares so that my middle terms cancel out and I don't have an I on the bottom. Then I'm going to simplify. So when I simplify the top, I'm going to change this to be negative 12. And I'm going to change this to be minus a negative 9, which becomes plus 9. Then I'm going to combine my like terms. So negative 10 and negative 12, what do those combine to be? Negative 22. And then a plus 15i and a minus 8i, those combine to be plus 7i. On the denominator, I have 4. These cancel out. Plus 9. 4 plus 9 gives me 13. So that is my final answer. Now this would be probably the most difficult problem that you would run into, so that's why we did it together. Just remember, anytime that you have a fraction, you multiply the top and the bottom by the conjugate, or by the opposite. It gets rid of the I on the denominator because the middle terms cancel out, and then you simplify. So you most likely will have an I on the top, but you should not have one on the bottom. It should just be a number. Yes?
So when you're multiplying by opposite, you just take the sign like between the two terms and flip it?
So since this is a minus, this becomes a plus. And those are the only two things that I changed about it. Okay, number 12, I'm going to multiply all of these together. So with the numbers 5, 8, and negative 2, I just multiply those. And so 5 times 8 times negative 2 becomes what? Negative 80. And then what do I do with the exponents? You add them because they are side by side. So 2 plus 5 plus 1 gives me what? 8. So I to the 8. Now, I don't want to leave my I to the 8th because your answer should never have an I with any power greater than 1. So you can only have an I in your answer, but do not have an I squared, an I cubed, I to the 4th. Don't leave those in your answer because that means it's not completely simplified. So what I do is I take 8 divided by 4, goes in it 2 times. My remainder is 0. So that means that it is going to match the I to the 4th power. And I to the 4th power is just what? It is just 1. So I to the 8th, I to the 8th is just the same thing as saying 1.
So whenever the remainder is 0, it matches 1?
Mm-hmm. It matches to the 4th power.
Oh, okay.
So my answer is just negative 80. Because it's like saying, okay, 1, 2, 3, 4, 5, 6, 7, 8. These all go together. And I would keep going 9, 10, 11, 12, 13, 14. So if it's if it's continuing the pattern every 4 powers, then 1, 5, 9, and 13 all have the same. 2, 6, 10, 14, 3, 7, 11, 15, 4, 8. So multiples of 4 all have the same pattern. Okay, number 13, I want you to change this to be 7 plus 2i. There's just a typo. And what do you notice about these two? The middle term would cancel out, and they're a difference of squares. So instead of like foiling this whole thing out, if I know that it's a difference of squares, then I square the first 2 terms, minus, and then I square the last 2 terms, and that's what it becomes. Now, if you don't feel comfortable doing that and you want to multiply the whole thing out, that's okay. But you will see that you would end up getting plus 14i minus 14i in the middle, and they would cancel out. So this is just a shortcut. And I'm not comfortable leaving this I squared there. What do I need to do? Change it to what? 49 minus 4 times negative 1. So 49 plus 4 gives me what? 53. So this whole thing is 53. Then I have 1 plus I squared. What can I do with this I squared? Make it a negative 1. 53. 1 minus 1. I did all of that for nothing because I get 53 times 0, which is just 0. I know, kind of sad. Okay, the next type of problem that you might get would be, and this is kind of where we are going to go with the imaginary numbers in this next section, is when you're solving for a quadratic and you have imaginary solutions, when you have a square root of a negative number. So for number 14, all that you're doing in this is you're solving for x. When you're solving for x, remember that you do PEMDAS backwards. We're going to do that more in the next section. If I want to get x by itself, I need to subtract 11. So 2x squared equals negative 48. Divide each side by 2. And when I square root, it's kind of the same practice that we did for 1 through 4. When I take the square root of negative 24, I'm going to have 2 answers. So you will always put a plus or minus out in the front. And then what did we say that was on, I think it's number 1, 2i root 6. Because it could be a positive 2i root 6 or it could be a negative 2i root 6. So just put a plus or minus out in the front. Okay, try number 15. Same kind of thing.